So let's go. Let's start today's session. So basically, today is our seventh number days. Okay, for advanced online training program or research-based training program. Okay, so let me share my screen. Just a minute. Okay, can you see my screen? Is it visible? Can you see my screen? So basically, today is our seventh number days, and today we discuss about some advanced topic. Basically, how to monitor the deforestation in machine learning, how to monitor the deforestation area and forestation area, or identify illegal logging area using Sentinel-2 and random forest classification. We also discuss about that slope classification, okay, and also area calculation, how to make the slope and also make the classification of the slope. And also discuss about that NDVI classification and area calculation, mainly how to identify vegetation density, okay, density and estimate the coverage area, and also discuss about that raster value extraction from GPS point. Suppose we have some GPS point, so how we can extract the raster pixel value, okay, for NDVI or any other data set, how to track the pixel value, mainly raster pixel value. Is discuss about that. So here I already opened some code. So if you check, okay, let me show you that. So first we discuss about this code. Basically, it identify vegetation density and also compute the area by how much area for low vegetation, how much area for medium vegetation, how much area for high vegetation. So you can also create the lot of classes. In this case, I simply create the free class again for this area. As well as if you check here, I computed the total area, okay, as a pie chart. So how much high vegetation, how much percentage, or how much low vegetation density area, or how much medium density vegetation area. We also just show you that. So this type of pie chart, if you check, so it show that high, how much area of the high vegetation, 22.6% area, the high or dense vegetation, and low vegetation, how much, 16.8%, and medium we find out that 60.60%. So I create the three classes, low, medium, high. So that's why it create this type of vegetation density area, okay, as well as for the exclamation area. So how I can create this type of things, I try to explain, then I hope you can also get the idea. So just I comment all of code together. So first of all, here I simply import the shape file. So this is my study area. So if you want, I will show you that. Suppose just I simply add the layer. So map dot add layer and call the AOI and run the code. So now it's loaded my study area. So this study area, I want to compute vegetation density. Okay, vegetation density I want to compute. So for that, first of all, I simply take this imagery. So this is my Sentinel-2 Surface Reflectance satellite imagery. So this is the Sentinel-2 Surface Reflectance satellite imagery. Further, we simply apply the three function: filter bounds function, filter date function, and also filter metadata function. Okay, so these three function simply we are use and filter our image collection. In this case, this image collection name is Sentinel-2 Surface Reflectance image collection. I want to check how many images I find out in here. I simply check it, just I call the data set and check how many images I find out. If you check, so it show you the computing the total number of images. Okay, and I put the time in 2023. So you can put any time, no problem. And I put the cloud pixel percentage less than 20. If I check, suppose less than 1%, how much image? Okay, less than 1%, how much image? We find out that we find out the 47 image. No problem. We can also use it because less than 1% image, it's very less cloudy image. So I just use and try to check the imagery. So for that, after that, we simply create a function. So it's a function. So it's a function. If you check, for the function, we simply create a variable name. It's a function variable name equal. I create a function keyword. I put the element name is the image. Okay, you can put any name. It's just like as a variable. It's just like as a variable. We can put any name as the elements. And in this curly bracket, we simply define our argument, what I need. So in this case, I simply create compute the vegetation indices NDVI. Okay, so this is the near infrared band and red band. We simply computed normalized difference between near infrared band and red band. Okay, and I rename it as NDVI. So now I return this image at a bands of NDVI. So now it this function create the band of NDVI. Okay, it's create the band of NDVI. If you check, suppose I will show you that just a print and call this data set. This is my previous data set. And I put here band names function. And now let's run the code. Sorry, it not works. No problem. We try to, okay, so because it's a collection, so I just simply run it. So it show the image collection and all of images. If you check the bands from the features, it show you the bands, individual bands. So you can see we find out this type of bands. Okay. So now I create the new band of NDVI. Okay, so I want to create the new band of NDVI. So for that, I simply create this function. Okay, so this function is simply create, and this function I need to connect with the image collection. And this is my image collection data set. This is my image collection, and this is my function. Okay, I simply connecting using the map function. I simply connecting using the map function. So I take a variable NDVI collection and call my dataset. This is my dataset. I simply call, and this is my function variable name. Calculate NDVI. I simply connect using the map function. So now further, if I just print the NDVI collection, just I copy and run the code. So now if you check, it create the another image collection. So now all of image at the new band of NDVI. If you check, suppose this image and check the band name, this band new band is the NDVI. Okay, so we simply create the new band of NDVI. So this band we simply create. Not only for that, suppose I create the another band, suppose NDWI. So how I can create? Same process. So I take a variable, suppose NDWI, and call the image and apply the normalized difference function, normalized difference between two variable, green P3 and near infrared B8. Okay, so this is the formula about the NDWI, and I rename it as a NDWI and put here add bands and put the variable name NDWI. So just I call this variable name. So now I create the another band of NDWI. So when I run the code, you can check what happened. In this image collection, all of images added the new band of NDWI. If you check all of images, it simply connect a new band, and this band name is NDWI. Okay, so this process we simply apply, and we can create any kinds of indices. It can be NDVI or NDWI or any others. Indices we simply connect with our image collection. Okay, so in this case, we simply work with the NDVI. So for that, I simply take a variable NDVI composite and call the NDVI collection, because this is the NDVI collection, and this image collection including all of images. This image collection including all of images with NDVI bands. So I simply apply NDVI composite, take a variable and call this NDVI collection and select the band of NDVI and create the medium composite. So now I want to display this map. I will just take a add the layer, map dot add layer and call this variable name NDVI composite. So let's try. We try to check this map. Just run the code. So now we added the new layer. If you check, it added the new layer. So we find out this type of map. Okay, it create this type of map. So now I need this map only for my study area. only for my study area I need this map. So for that, after median function, just use the clip function. Clip with your study area, mainly your shapefile, your geometry. So in this case, it's a AOI. So just I apply AOI and now run the code. So now I can easily get this NDVI map for my study area, okay, without color. How I can add the color? So for the adding the color, just make a dictionary. I put suppose mean and also put the max value and add the color plated. So I put the color plated and add the some color. Suppose I put the color um suppose I put here that white color or put here suppose blue color and suppose put here white color and put here suppose yellow color and suppose put here the green color. You can put any different types of color and also put the mean and max value we can easily get from this layer. Just click on here and if you check it open the visualization parameter. I click on the custom and I change it as a stressing 98%. So now it automatically show you that minimum and maximum range of NDVI. It's working. Takes some time. Okay. Just I copy the range, minimum range, and paste here. Also copy the maximum range and paste here. And now run the code. So now it's adding the colorful NDVI map. So from where you can easily get the all of yeah. So you find out you can see this type of vegetation map look like that. Okay. So you can easily get. So this type of green color indicating about that vegetation area. So now from this vegetation area, I want to monitor vegetation density, mainly where is the low vegetation density, where is the medium, where is the high. So this is my main target. I want to identify vegetation density. Where is the low density, where is the high density, where is the medium density. Okay. So for that, we simply create a threshold value. So in this case, I simply take the two threshold value. If you check, I put the one threshold value 0.2, it's a low, and high 0.4. Okay. So we simply apply the two threshold value 0.2 and 0.4. It's a low threshold value and it's a high threshold value. After that, we simply create a function. We simply create a function, and in this function, we simply apply the some condition. If the NDVI value less than equal 0.2 and NDVI value greater less than equal 0.4, basically high is the 0.4 and low is the 0.2, we make a one class and we define NDVI. It's just come from the NDVI composite. NDVI composite. So I already create the NDVI composite and define a high and low. So further we simply create the classes. If you check, just I create the three classes. I put three color and we simply run the code. So now it will be added. So between this range 0.2, 0.4. Okay. Suppose NDVI less than equal 0.2, one class. Then NDVI less than equal high, this is another class. We just simply create and also create the another medium class. So we simply define this type of color. If you check, so it create this type of suppose this type of place, it's a low vegetation or there is no vegetation this type of place. So mainly we find out this type of place is the vegetation, it's a high density, is a low density, and this is the medium density. This type of place we find out that. So it create this type of density. So further we simply create the area, how much vegetation for the low density or medium density. Okay, okay, just let me add the listen and get the idea. Okay, just this is the listen code, just I run. We find out, you can see this type of things: basic density, low, medium, and high, based on the NDVI range 0.2 and 0.4. So now we try to compute it how much vegetation density for the low, yeah, medium, and high. So for that, we simply apply. So we create the pie chart. Okay, we create the pie chart. So for this pie chart, we simply define a variable area image. and apply ee.image.pixel area. So it compute the area in square meter, all of pixel, and I add bands with the classified. So basically, this is my image, this density image is stored in this variable. So after that, we simply apply the reduce region function. Just apply the reduce region function, and then just simply create the class area list, and also add all of those necessary argument for the low, medium, high, and finally create the pie chart with the level of level, mainly brown, yellow, and green. It's a color indicating about the individual pie chart area. It creates this type of pie chart if you check. Or if you want, you can, in this case, simply create the three class. If you want, you can also increase the class. Okay, just apply the different types of threshold value, then it will be work. No problem. So now talk about this code. So basically, if you check, it creates some it create the slope. Okay, and also make the slope slope class. Suppose 0.5 degree. Okay, it create the one class. 5 to 10, it's another class. 10 to 15 degree, it's another class. 15 to 20 degree, it's create another class. Okay, it creates some class. Also 15 to 20 and greater than 30. Okay, it creates another class. So this is the slope classification map. Okay, so if you check, this is the slope. It's a slope map, and this slope map we simply create the classification, and we can easily get 0.5. So this type of green color indicating about the 0 to 5 degree slope. Okay, this type of place, 0 to 5 degree slopes, and you can say 5 to 10. So this type of color and this type of gray color, it's indicating about that slope greater than 30 degree. Okay, so this type of red color indicating about that slope in greater than 30 degree. We find out the 30 degree, this type of red color. So it's very easy. We simply import our data set. So in this case, we simply apply the NASA SRTM data. It's one kind of DEM data. It's provide you the elevation or elevation. So from this elevation, we simply compute the um, slope. So further, we simply apply. So we simply take the steer and select the elevation. Okay, and further we simply apply this function e.print.slope and compute the slope from this DEM data. Okay, and clip with our study area. And now we simply apply this type of range. Suppose 0 to 5, we create the one class. 5 to 10, it's another class. Then 10 to 15, it's another class. 15 to 20, another class. 20 to 25, another class. Okay, so further we simply apply this classification if you check. So study area slope, basically this variable stored the slope map. This map, it stored this map. So I simply call the study area slope greater than 5 and study area slope less than equal 10. We make a one class. Then 10 to 15, another class. 15 to 20, then 20 to 25, 25 to 30, and 30 to 100. Okay, all of those we simply create this type of classification. And then simply add the color plated. Okay, and also add the map. So we find out this type of classification map. Not only for that, we also calculate the area. If you check the area, suppose class 1, how much area? Okay, basically class 1 is that 5 to 10. Okay, 5 to 10 degree slope area. How much? 83.71. Then if you check how much class 2 basically 10 to 15. How much area? Then if you check suppose all of those one by one, and if you check this is that greater than 30, how much area? So we find out that this is the 1677 square kilometer area of area is the greater than 30 degree slope. So this is the way we simply use the NASA SRTM data, and further we simply identify for the slope classification. Okay, this type of range. If you want, you can also change this type of range. Okay, and also identify for the classification. Just simply change in here. It also better, no problem. Okay, anyone in question, you can ask me in here. I also send you this type of code. You also try to practice for your own study area. Further face any problem, we'll also discuss about the problem. Okay, I hope there is no problem. So if you check, this is another.
No,
So
thank
in this
you.
case, we simply apply the deforestation and forestation classification for this study area. So let me zoom. Okay. In this time, this type of color indicating about the deforestation area. This type of color. Okay. This type of indicating about the deforestation area. Okay. There is no vegetation or there is no forest. But this type of green color is the forest. In this case, basically in this time we simply apply the Landsat satellite data. And if you check this, the Landsat satellite data, we simply take again Landsat surface reflectance composite, and we are just use this type of bands. Okay, and we take the manually we created the polygon forest. Okay, we create the this type of polygon. It's a polygon. Okay, rectangle. You can say it's rectangle. So this type of rectangle is simply generate. Okay, manually forest and non-forest. So this is the forest, and this two is the non-forest one, non-forest two, forest one and forest two. Basically, these two things we simply use as a training sample. Okay, for forest and non-forest. So we find out this type of place there is no forest. It's a non-forest area. Okay, and if you check, suppose if I want, I'll also try to show you this type of layer. To check the training polygon. That is it. Okay, from here, just let me show you that. So if using this type of polygon, so this type of polygon indicating about the training sample. Suppose for the forest and non-forest. It's a forest, you can see it's a forest, and this type of place is a non-forest or deforestation. This type of color indicating about that there is no forest. This type of color. So also this is the forest. You can see it's a forest. Green color, it's a forest, and you can see it's a non-forest. Okay, this is a non-forest. So this type of training sample is simply generated as a polygon. As a polygon. So this type of place is the forest area, and this type of place is the non-forest area. So we take the training sample for the forest area, this one, and also this one, and this is a non-forest. It's a non-forest area, and it's also non-forest area. And further, we simply apply the machine learning method, okay, and then compute, make this type of classification. Okay, in this case, we simply apply the support vector machine. Create the support vector machine. We have put the kernel with the radial bias function, comma 0.5 and cos 10 degree. We find out in here. Okay. So this is the support vector machine algorithm. We simply apply because support vector machine is work very well for two classes. Okay. So when you identify for two classification, suppose forestation and deforestation, or any two classes, when you want to classify, then try to use the support vector machine. Then we simply create this type of deforestation area and also forestation area. So you can see this type of color, orange indicating about that deforestation. Okay, it's a deforestation, this type of color indicating about that. And this type of color indicating about the forest area, the forest area. And this type of place is the deforestation. It's a deforestation area. It's a deforestation or non-forest area. A non-forest area, this type of place. This type of forest area. So I also send you this code. You also try to practice for your own study area. Compute this type of things also. Okay? And further, if there's any problem, let's discuss about this type of problem. Is the forest and non-forest area, how to classify it. Okay, okay, so okay, it's not a problem. This is the another forest monitoring or forest cover change. So in this time, if you check this type of indicating about the forest cover, okay, green color. This type of red color is indicating about the forest loss. This type of color is the forest loss, and this type of color indicating about the forest gain. Okay, and this type of indicating about the gain and loss. Okay, so this is one kind of ready-made product or ready-made data set. If you check this data set, it's called that. If you check the data set, let me show you that. It's a Hansen data set. If you check, basically it's identified. Let me show, open from here. Hansen Global Forest. So it's one kind of data. So from this data, we can easily get all of information. Tree cover, then loss. Okay, you can see the tree cover basically tree canopy cover. Year 2000 and defined as the canopy for all vegetation taller than 5 meters in height. And loss, it's a forest loss during the study period. And loss bit marks, not loss and loss. And gain, if you check, so it's a gain. So forest gain during the period 2000 to 2012. And also you can see the loss year. Okay, so it provides some ready-made product. So this data set we can also use and identify type of things. And you can see it's available between this time period 2000 to 2024, December 31. Okay. So this data set is also useful for the forest monitoring, mainly loss and gain, gain and loss, or also forestation or afforestation. We also use this type of data. And you can see this result, it time series analysis of landscape imagery. Okay. So it just use the landscape imagery and create this data. So for that, if you check the analysis, so first of all, we simply import our image again, and then put our study area and take the I take the Brazil country boundary, and further we simply call the image and select the loss year, one kind of band. Okay, we simply select the band for the loss year, image and select the loss, and image also select the gain band and select the tree cover and clip with our study area. Okay. And then simply apply the using AND function or AND method to merge gain and loss. So simply apply the AND function to merge the gain and loss, and also visualize the tree cover. If you check the tree cover, so basically this layer, we find out this type of forest cover area. Only for the forest cover area, we try to max. We find out this type of have the forest covered area look like that, green color. So after adding the forest cover, we simply add the loss. Okay, if you check, this is the loss. This type of red color indicating about the loss of forest. Type of red color, it's indicating about the loss of forest. As well as same, we try to apply suppose a gain. This is the gain layer, gain, to check this type of color. So we're indicating about the gain forest. And finally, gain and loss. So we find out type of layer. Type of color indicating about the gain and loss. This type of place. So this data is very helpful. You also try to use the Hansen data and monitor the forest cover. Or it's globally available. You can use it for any forest area. This is another very popular. So basically, it's identify about the time series of deforestation. Okay, suppose for yearly or different decade, how to monitor the forest deforestation. We also try to discuss in here. So for that, we simply apply the Lancet 4, Lancet 7, Lancet 9, Lancet 8, and 5. So all of Lancet collection we simply apply. And this is my study area. Okay. And we simply create the list. Suppose I want to monitor the deforestation for this type of time. 1990, 1995, 2000, 2005, 2010, 2015, 2020. Or you can put any time period or any decade between the Lancet. So now we simply create a function. So this function basically simply used to filter our image collection. And also this function is simply used for that removing the cloud and haze, removing the cloud and haze, and also rescaling our bands. Okay, rescaling our bands. Further, simply also this is the same code for rescaling our bands and also removing the cloud shadow or other unnecessary pixel. Okay. And then we simply create the composite. So we simply create the composite, Lancet 457, create the median composite, and also Lancet 8 and 9, create the another composite. Okay. So now we simply apply the yearly image collection from 2014, 2000, all of yearly image collection from 1990 to 2020. Okay, all of those. If we say we find out this type, okay, so further we simply apply the index, vegetation index, near minus short wave infrared divided by near plus short wave infrared, and make the VI, basically vegetation index. And forest, we simply choose the forest 0.6 to 0.7. Okay, so this range we simply consider as a forest. So we simply call the vegetation index greater than 0.7 and self marks. Okay, and forest area also computed. Okay, for the per year, and visualize this type of things. If you check, it creates this type of area chart for forest area. We find out this type of, you can see for the forest area 0.3, it's a hectare unit. We find out that, and you can see it's increasing or decreasing for this time, and also decreasing for this 2005, then 2010, 2015, or 2020. It will show the forest area. We find out. Uh, and further, we simply apply this type of listen also in here and make this type of analysis. Or if you want, you can also download all of layer together. If you check, it show you that this type of result. So this is the surface reflectance image 1990. So this is a satellite imagery surface reflectance. Find out, if you check, it show the imagery in 1990, 1990, and this is a vegetation index map 1990. Okay, this is the vegetation map. And same, this is the forest 1990. Check the forest. So this is the way. If you check, this is the image. This is the image, and using the image, we simply compute the vegetation index, and then use simply apply the threshold value 0.6 to 0.7 and identify forest area. Okay, so we find out, you can see this type of place is the forest area. We find out that, simply apply. Then yes sir, this is the image 1995. Further identify vegetation and also identify forest area for 1990. So you can see, just create the three layer for one image. So this is a 2000 imagery. 2000 vegetation index, and 2000 forest, then 2005, 2005, then 2010, and finally 2015, 2015 and 2020. Okay, and I create this type of forest here to check. It's mainly merge all of forest 2000, 1990, then 2000, 2005, 2010, 2015, and 2020. So we find out that this type of map. Okay, so you can see this runs, we find out this type of color. Okay, and current forest, we find out this type of green color indicating about this type of place is the current forest. Okay, any question you can ask me, please. Any question? Okay, so it's very important. So previous class I discussed about that how to work with drought monitoring using vegetation condition index or vegetation health index, and use the modis satellite data. We will use the modis satellite data, but if you want you can also use at the landsat data and also do this type of analysis. So this is the same concept, but in this time we simply apply the landsat satellite data. Okay, so this is the landsat satellite data. So if you check, so as the same with this code also, it is to try to practice, okay, and try to do what that for any study area, just use the same code. Okay, you try. And these are time series chart. So you can see find out this type of place. This is the node rod. Okay. And this type of place is the high rod. Okay, this type of is the medium. Okay, you can see this type of place, there is node rod condition. So you have to try for your study area for identified road scenario.